from a TED thing. I'm not quite sure if I can get enough volume out of this thing so you can hear it. This may not be loud enough. This is
my next car gets 100 miles per gallon. I'm Joe Justice. I'm a Seattle area software consultant, and I'm a member of Team wikispeed.
Yeah.
Team wikispeed has built a fast, affordable, ultra-efficient, safe, fun commuter car. And the first prototype, functional prototype, was built in 3 months. How is that possible when existing cars seem to change so slowly? Here we see, over a 6-year period, a mainstream hybrid car achieved an additional 2 miles per gallon. Existing manufacturing processes are slow because they're very expensive to change. If an engineer wanted to redesign this door tomorrow, they would need to wait 10 years to first pay off the current door mold before making another one for relatively millions of dollars. This is not uncommon in manufacturing teams for them to run on 10 to 25-year development cycles. Old software teams used to run the same way. We use 7-day development cycles. This is how new software teams run, and it allows us to make changes very quickly. In 2008, the Progressive Insurance Automotive X Prize announced a $10 million prize purse and an international challenge to see if it were even possible to build 100-mile-per-gallon cars to road legal safety specifications. The closest thing we had in 2008 were like bobsleds. They achieved more than 100 miles per gallon, but they held 1 occupant, and they didn't meet road legal safety requirements. I joined the X Prize too, but in the beginning it was just me. But I decided to blog about everything that went well, and everything that didn't go well, and everything I was learning. And through social networking tools, a team came to assist. And 3 months later, we had the car that we campaigned in the X Prize, and a volunteer team of 44 team members in 4 countries. We tied for 10th in the mainstream class. That meant we outlasted more than 100 other cars from companies and universities around the world. We do this by modeling our team to develop the car after modern software teams. We use techniques with funny-sounding names like Agile, Lean, and Scrum. Right after the X Prize, we were invited to the largest auto show in the world, January 2011 in Detroit, Michigan. We knew we wanted a more beautiful car, a more aesthetic car, but we also knew that for 1 car body, it would cost us at least $36,000 and 3-month lead time. These methods all help us make changes quickly. So I took time off my day job, and I went to composite school. I came back to the team, and we made small models of the car and iterated a composites process that ended up letting us build our car body in structural carbon fiber in 3 days for $800. You guys are awesome. Thanks so much. They put us on the main floor of the auto show between Ford and Chevrolet. Lucky for us, the car was beautiful. That car went on to be featured on the Discovery Channel, Popular Science, Popular Mechanics, the New York Times Online, the National Geographic Channel, Wired Magazine, the Forbes Billionaire Club linked to us, and others. Now, and this has been a 6-month time span, most of what I'm talking about. Now, Rob Moorbacher, who leads our Germantown, Maryland team, is producing our production convertible city car mold. So how do we do it? We're modular. The engine is able to be switched from a gasoline to electric engine in about the time it takes to change a tire. The car body switches from a convertible to a pickup truck. This lets us make changes and develop quickly. Here you can see our chassis, our frame, holds all the modules together. That chassis is the lightest chassis in the world to achieve a 5-star crash rating of the low speed.
Americans, they thought everything.
Thanks so much.
When was this made?
This was last year, I
We
think.
design safety tests for our parts before we even build them. In fact, we design tests for all of our parts before we build them. We take this from test-driven development to the software world. You guys are awesome.
Come on.
We use less stuff wherever we can. Here, Rob Huggins, a Seattle area recent high school graduate, is saving up for college, and he's able to build a wikispeed car by using an $89 bandsaw and a home-built CNC router instead of a piece of equipment that costs more than $100 million in existing automotive process. We reduce the cost to make change wherever possible. Cost in tooling, machinery, and complexity. This lets us not have to wait 3 to 7 years for the next version of our product. Again, we're able to make changes to any part of the car every 7 days. We use distributed collaborative teams. These, again, increase our velocity. And we found that morale is a multiplier for velocity across the team. The way we organize our teams is the smallest, fastest way to organize an agile team is called Scrum. Scrum is a method to manage a team in a very rapid way, and that's exactly how we manage our teams at Team Wikispeed. We do all our work in pairs. This avoids time spent training that's not productive. It also eliminates the need for most types of documentation. Here, Martin Val and Kurt Roy are building one of our engines. They actually both perfectly know how to do it, but they're able to share all that knowledge while working without then having to up-train someone afterwards.
I was at a conference earlier this year. Over 3 days, it wasn't from scratch, but they shipped the parts in, and they trained up by pairing, like I was talking about. So it was one experienced person, one random person picked out the conference. And this wasn't like an engineering conference; it was a computer programming conference. So these people weren't car builders or anything like that. Built the car over 3 days. From scratch. They had it up on the podium at the end, and this was their, as it were, the first one that they're actually selling. Which gets 100 miles per gallon. It's not like a really nice car. It's more kind of like a kit car type thing inside. It's not got your CD player and everything, and it's a rough ride. But it's there, and it's being sold in very small numbers because they're basically still building it by hand. But they've gone from nothing to selling a car that gets 100 miles per gallon in less than 2 years. And this is not a major company. This is not, a massive government-funded thing. This is just people with engineering skills getting together, networking, using kind of all the social media type stuff, the Skype and all that sort of rubbish, so they can communicate globally, because it's not just an American thing. There's bits of Wikispeed in the UK and in Brazil and in lots of different countries. And I've forgotten my point. Distracted.
Just to be your point, they were just very quick.
They were just very quick.
But they were quick because they deliberately chose to use this kind of lighter, more agile way of organising themselves and optimise the speed of absorbing feedback.
And also they were using, I remember my point now, using equipment like the cheap computer-operated CNC machines that you can get these days, cheap 3D printers for prototyping some things, kind of this off-the-shelf 3D modelling stuff that you can get these days to help build these things that would have cost thousands or millions of pounds and be kind of expert things that only General Motors can afford, and now in the hands of normal people. And there's an enormous amount of untapped power there. And Wikispeed are also doing that. They're taking on other projects now. They're looking at things like how can we make cheap refrigerators for vaccines and stuff like that. They're trying to try out other things. So I'd urge people to go to look at their site because they're doing cool stuff. Whether they're going to make money out of this now, I don't know. I think they're founded as a non-profit, but I'm not 100% because it's only something I only first heard of them at this conference sort of thing when they were presenting this. So I've been kind of poking at it since because I'm obviously interested in it from kind of the agile side, and they're applying stuff from my world into the engineering one. and it's very cool. And it's doing stuff that to me would have been completely unimaginable 10, 15 years ago.
Can I point out, as an end user of products in both like physical world and software world, a big drawback that keeps on coming up to me every time I come to consider the advantages of having produced this stuff is the disadvantages of having to buy this stuff. If you buy a car and it does have a few drawbacks, then it's like when you say, you know, I want you to like find by putting a CD player in it, and they say, well, no, that means because we don't like make that of last week. Now you've got to buy a whole new car that's got a CD player.
Well, actually, what you can do, and what they've already done, is what people have done in Ford, some of the early ones, because it's a modular design. They've gone, oh, you want the new doors now? Fine, here are the new doors. They're really easy to set.
They designed them to be,
you know, they didn't go out with that idea in mind, but that happened. I can't remember if it was car doors, but they've shipped new things to people with some of the early prototypes because they asked for them. So there are different models of buying stuff. You're right that the model of how you purchase this and where the money comes, that is an entire conversation. And there are ways and means around it.
No, but you satisfied my curiosity
Okay.
as to whether that's implicit in the model. And you told that. I mean, you showed me that it's not guaranteed that people will have to buy a new car every week just to get the improvement.
Yeah, there are, and the other way to think about it, is it any worse than the old one? You know, you only bought a car then and you had a car, you know. So.
Well, no, because the things will be available over a long time and people will like know the car inside out, just that one version, so they'll be able to tell you absolutely what could and couldn't be done. And you know, that's the kind of engineering that I was used to.
but the best way to probably solve that problem would actually be, because these projects are open, they're open to kind of everyone contributing, is to not have, let's say, design the thing and launch it, and then have trained, you know, people at the garage or something who kind of learn about that particular model. It's to include the people at the garage as part of this wider community who do the initial open design, so that people in the garage are always kind of following, and the people who are going to modify for the final customer are much more integrated with the whole design process, so that it's always being so they're continuously learning as well. See what I mean?
I had much the same experience with mobile phone companies that was like stopping me from getting messages off my phone. They say that the software used to do this, but then repackaged it and made it so I couldn't translate the messages. I was ringing up Nokia, I was ringing up Wii, constantly trying to say, look, I just want to back up my messages in a format I can
But that's much more likely.
Nobody knew.
Yeah, but that's much more likely because 3 is deliberately trying to kind of take control of you and isn't trying to kind of make things easy for you, and it's because it came out of an agile process.
Someone just made a decision that made it impossible at the end of it. But Nokia were like, well, they were trying to bend over backwards to help me, just one end user, not even giving them any direct money, trying to say, well, yeah, we want this to be possible. Well, we didn't know that 3 had been done.
Yeah, sure.
So it would be so, you know, universally inhibited.
Yeah.
So, you know,
Well, that's the badness of projects being kind of closed and not being open to lots of people to sort of engage with them. In a sense.
Okay, guys.
I think I'm concerned because we've got someone else coming in on Skype now to talk to us.